When I go in the arena, make the ground shake, make the ground scream. Me feeling knock out the enemy. Bring the fire when I fight to the melody. Blood fire, you beginner. Keep on the game, me a winner. Your man them know me a leader. When I come in the arena. When I come in the arena.
Dramatic advances in technology over the last few decades have led to tremendous improvements in all aspects of life. But humanity still faces a host of complex challenges: environmental quality, the production of clean energy, water supply, and human health. The solutions to these challenges lie in breakthrough scientific developments and technologies. The Faculty of Mechanical Engineering is working to develop solutions to these challenges at the forefront of research and technology, and with a constant eye towards the future. This is our mission: to harness science and engineering for the good of humanity.
I head the Microfluidic Technologies Laboratory. One example of our work is in the field of medical diagnostics. Lab on a Chip is a vision that we are part of that aims to take large-scale chemical and biological laboratories and reduce them to the size of a small microfluidic chip, such that a nurse or a doctor in their office would be able to take a sample and get the result right there on the spot. The ability to achieve point-of-care diagnostics is an important enabler towards personalized medicine, which we see as an important part of healthcare in the 21st century.
In our faculty, an interdisciplinary approach is the name of the game, because that's where the future of research lies, connecting experts from different fields of research to create breakthrough outcomes. The faculty's researchers bridge robotics with medicine, translate fundamental physics into optical applications, create advanced materials, and develop smart control systems.
In recent years, photovoltaics became the most cost-effective energy conversion system. What is missing is the ability to store this energy in order to get day and night solution. And this is what we do. We invented a concept that is based on material that absorb the solar radiation and emit low energy photons. We have a unique system that doubles the total efficiency, and by our calculation, the cost of such a device may be 66% of any other technology. And my dream is to be part of this global change.
It's no coincidence that the Faculty of Mechanical Engineering is developing a robot that's activated by the power of thought, a mechanical system that improves heart activity, advanced robots that can overcome physical obstacles, nanoscale parachutes that monitor air pollution, and advanced technologies for smart and energy-efficient buildings.
We have demonstrated mechanical communication, that is the ability of cells to sense and respond to mechanical forces generated by their neighbors. We were able to modify spontaneous beating frequency of cardiac cell using a mechanical cell, that is a device that mimics the deformation that are generated by a beating cardiac cell. The physiological significance of this phenomena is that while the frequency of cardiac cell beating in the heart is determined by pacemaker cell, mechanical communication is required to synchronize the phase of cardiac cell beating, and therefore is essential for synchronized contraction of the heart.
About 40 faculty members working in 3 research centers and in over 35 laboratories teach and train the next generation of mechanical engineers in a variety of degrees. These include 900 undergraduate students and 400 graduate students, comprising the faculty's most valuable asset.
It's very important nowadays to develop next generation water technologies that are more available to first and third world countries and that can do water desalination and treatment at lower cost and selectively. And so we're developing a technology called capacitive deionization, which meets this criteria and that we hope is going to form the basis of next generation water treatment and desalination technologies.
Many startups have emerged from the faculty, and they too are committed to providing technical solutions to social, economic, and environmental problems. Companies such as Mazor, which was sold for $1.6 billion. The company developed a robot that assists with complex back surgeries and saves the lives of many patients around the world.
We at the Faculty of Mechanical Engineering are seeking the best and brightest students. Students who have the scientific curiosity, but also the drive of an engineer to take this understanding and leverage it toward creation of new tools, new capabilities that no one has ever done before.
The Faculty of Mechanical Engineering at the Technion continues to be ahead of its time with groundbreaking research initiatives. We will continue to train our students for diverse, engaging, and fulfilling careers, and to develop future technologies for the benefit of Israeli society and for all of humanity.
Good morning, everyone, and welcome to the 16th Nadav Shoham Robotraffic competition. Today, more than 20 teams from around the world have gathered here online to take part in a global celebration of robotics, autonomous driving, and innovation. Some of you arrived after months of coding, debugging, redesigning, and testing again and again. Behind every robot here is a story of persistence, creativity, and teamwork.
It is my pleasure and privilege to welcome you to the 2026 Nadav Shoham Robotraffic competition at the Technion Israel Institute of Technology. This competition is already well established in its 16th year, commenced as a local tournament in Israel and developed into an international one with over 100 competing organizations. Over the course of 16 years, we've been able to track the participants' enthusiasm and the information they've gained to maturity in university studies and high-tech sector roles. I would like to thank our partners for their contribution to this amazing project: the Faculty of Mechanical Engineering at the Technion, the Leumi Robotics Center, the International Earth Organization, the World Scientist Organization, NVIDIA, and the YTech Foundation, of course. Investing in robotics is, as I see, essential for those interested in keeping up with the forefront of innovation. I wish you all a successful and educated Robotraffic competition. Good luck, you all.
Artificial intelligence has moved in recent years from research laboratories into real-world applications at an unprecedented pace. What once required highly specialized systems is now embedded in everyday technologies, from navigation systems to recommendation engines, and from industrial robotics to intelligent transportation systems. This rapid transformation is not only changing industries, it is reshaping the skills the next generation will need to master. This competition is about more than robotics. It is about learning how to think, how to solve problems, and how to turn ideas into real systems. Autonomous driving is one of the most demanding applications of artificial intelligence because it operates directly in the physical world, where uncertainty, motion, and safety are critical. Unlike software systems that operate in controlled environments, autonomous vehicles must constantly interpret incomplete and noisy data, predict human behavior, and make safety-critical decisions in real time. This combination of perception, prediction, and control is what makes autonomous systems one of the defining engineering challenges of our time. Science, technology, engineering, and mathematics are the language of the future. STEM education develops more than technical knowledge. It builds analytical thinking, creativity, collaboration, and resilience, all essential skills in a world defined by rapid technological change. These are not only skills for engineers, they are becoming fundamental skills across every profession. Artificial intelligence and robotics are no longer technologies of the future. They are already transforming the world around us. From healthcare to manufacturing, from logistics to transportation, intelligent systems are becoming part of everyday life. Nowhere is this transformation more visible than in autonomous vehicles. An autonomous vehicle is a real-time decision-making system. It must sense its environment, interpret complex data, predict movement, and act safely, all within fractions of a second. To achieve this, autonomous systems combine mechanical engineering, computer science, artificial intelligence, mathematics, and control theory. It is one of the most complex engineering challenges of our generation. We are now entering the era of physical AI, where intelligence moves from screens into the physical world. Robots can see, move, grasp, navigate, and interact with humans and their environment. This convergence of intelligence and physical action represents a major shift in how technology is designed and deployed. This is why STEM education has never been more important. The World Economic Forum reports that artificial intelligence, robotics, and data-driven systems are among the fastest-growing fields in the global economy, and that future jobs across nearly every sector will require strong technological literacy and problem-solving skills. What you are doing here today is not only a competition, it is a simulation of real-world engineering challenges under constraints of time, uncertainty, and performance. And in that sense, every decision you make here reflects the same principles used in real autonomous systems development. Transportation safety remains one of the most important global challenges. Human error continues to play a major role in road accidents worldwide, despite advances in vehicle technology and infrastructure. This is why autonomous systems are being actively researched across the world, not only to improve efficiency, but to reduce risk and potentially save lives in the long term. This year, there are 4 different categories in which the teams can compete. The categories are careful driving, racing, traffic safety initiatives, and 3D CAD. The main challenge in the Robotraffic competition is to build an autonomous robotic car model that can move according to the traffic rules, obey traffic lights, and keep a safe distance from other cars. This year, the teams need to create the track, the lights, follow the guidelines, and deal with any issue during the competition. The teams competing in the racing and careful driving categories will present their work live to 3 judges via Zoom. In the Traffic Safety Initiatives category, teams present innovative ideas and technologies designed to improve road safety, reduce accidents, and create smarter transportation systems. Participants are evaluated not only on the originality of their solutions, but also on their practical impact, technical execution, and potential for real-world implementation. Finally, the teams deliver a polished presentation summarizing their development process and showcasing their proposed solution. The judging is based not only on innovation and originality, but also on the quality of the presentation, the clarity of the ideas, and the overall level of effort and execution. In the 3D CAD, teams are challenged to demonstrate both engineering knowledge and technical design skills through a dedicated annual assignment. For 2026, participants are required to create a detailed air suspension strut, explain how it works, and describe the purpose and advantages of fully active or adaptive suspension systems. The competition is designed to deepen students' understanding of automotive engineering and vehicle construction. Teams are evaluated on the quality, accuracy, and complexity of their models, as well as on their ability to clearly explain the engineering concepts behind their design. Each team must also prepare a professional presentation and an explanatory video, which are submitted in advance to the Technion. In addition, participants take part in a live Zoom interview where judges ask technical questions about the project. The final scoring is based on both the quality and sophistication of the CAD model and the clarity and persuasiveness of the team's oral explanations. In the racing category, competitors race against the clock with one goal: achieving the fastest possible time from the starting line to the end of the track's S-curve. The timer begins the moment the traffic light turns green and stops when the car reaches the wall at the end of the course. To complete a valid run, the vehicle must stay within the track boundaries at all times. And as you're about to see, even the smallest adjustments to the cars and their code can make a dramatic difference in performance. In the careful driving category, the vehicles must navigate a track featuring traffic lights that must be obeyed and obstacles that must be avoided. The winning team is the one whose car completes the highest number of laps within 2 minutes. Leaving the track, hitting obstacles, or failing to obey the traffic lights all result in penalties. And trust me from past experience, the competition is always incredibly close and intense. This competition is held in memory of Nadav Shoham, whose passion for robotics and education continues to inspire students around the world. His legacy lives on through every student who chooses to build, create, and innovate. As Professor Moshe Shoham has emphasized in previous years, the true value of this competition is not in rankings or results, but in the knowledge and experience gained along the way. Innovation grows when ideas cross borders, when students collaborate, and when curiosity becomes creation. The Technion has always been at the forefront of scientific and technological innovation, and today it continues to shape the next generation of engineers and scientists. On behalf of the Technion and all partners, we wish all teams the very best of luck. Let the competition begin.